Time.
It rules our lives, yet it slips through our fingers like sand. We age by it. We measure it. We chase it. But what if time was not a prison? What if it could be bent, stretched, or even paused at will? What if the ultimate invention, a machine capable of manipulating time itself, was not just science fiction, but a possibility within reach? This is the story of the invention that could bend time, the dream, the science, the danger, and the unimaginable possibilities. Sweeping shots of bustling cities, sunrises and sunsets in fast forward, galaxies spinning, black holes warping space-time, clocks ticking. Before we imagine bending time, we must first understand it. For centuries, humans believed time was absolute, a steady, unyielding march from past to present to future. But then came Albert Einstein. His theory of relativity shattered our understanding of time. He showed that time is not universal. It is flexible. It can stretch, bend, and even slow down depending on gravity and speed. Time, as we experience it, is not absolute. It is relative. In other words, if you travel near the speed of light, time for you slows down compared to someone on Earth. Drop something into a black hole, and it could freeze in time forever from our perspective. These phenomena were once theoretical until technology began to explore them. Archival photos of Einstein, space-time fabric animations, clocks on satellites. Long before Einstein, humans dreamed of controlling time. Myths, legends, and literature explored the idea. H.G. Wells' The Time Machine, or ancient tales of immortals who could escape time itself. But these were stories. Imagination alone could not bend the flow of time. That required science, and science required understanding the universe at its deepest level. So, how could we actually bend time? The answer lies in two pillars of modern physics: relativity and quantum mechanics. Einstein taught us that massive objects bend space-time, and that bending affects time itself. This is why a clock on a satellite runs slightly faster than one on Earth. It experiences weaker gravity. By harnessing extreme gravity or near-light speed travel, we can theoretically slow down or accelerate time. Quantum mechanics, meanwhile, opens doors that are stranger still. In the quantum world, particles can exist in multiple states at once. Time crystals, a concept recently proven in laboratories, are materials whose atoms move in patterns that repeat in time, rather than space. These are the first glimpses of materials that could allow controlled manipulation of time itself. Combine these ideas, relativity's flexibility and quantum mechanics' strangeness, and you begin to glimpse the blueprint for the ultimate invention, a machine capable of bending time. Animations of space-time bending, quantum particles, lab footage. While we're far from a full-scale time machine, researchers around the world are making progress. One example is time dilation experiments. Flying atomic clocks around the world at high speeds confirms that time slows down for fast-moving objects. Then there's quantum entanglement, particles affecting each other instantly, no matter the distance. Some theorists suggest entanglement could allow information to travel backward in time, a phenomenon called retrocausality. Time crystals, discovered in 2017, are the first materials that oscillate in time without using energy. They could be the building blocks of machines that control small moments of time. And finally, theoretical physicists have proposed warped space-time machines, using intense gravitational fields or exotic matter to create tiny bubbles of warped spacetime, mini-time distortions that could slow, speed up, or loop time locally. The technology doesn't exist yet, but the equations say it could. The implications of bending time are staggering. In medicine, surgeons could gain extra hours for critical procedures. In computing, time loops could accelerate calculations, solving problems in fractions of a second. Communication could be transformed, with quantum entanglement allowing messages to travel faster than light, effectively sending information through time. Space exploration could take advantage of time dilation, sending astronauts far beyond the limits of human lifespans. Even in daily life, small-scale time manipulation could let us extend moments of joy or accelerate tedious tasks. The possibilities are breathtaking. But with great power comes profound responsibility. Bending time isn't just a scientific challenge, it's a moral one. Who decides how time is used? Could it be weaponized to alter events or gain unfair advantage? Could we create paradoxes, accidental loops, or even irreversibly change history? Time manipulation could be the ultimate tool or the ultimate threat. Philosophers, ethicists, and scientists are already debating these questions. Controlling time isn't just physics. It's about controlling reality itself. So, what does the future hold? Will we see a true time-bending invention in our lifetime? Most likely, the first devices will be small-scale, slowing down reactions, manipulating quantum states, or creating localized time effects. But even these first steps could revolutionize science, medicine, and technology. And as our understanding of physics deepens, one day humans may bend time itself, choosing moments to extend, repeat, or even revisit. Time has always been our master. We've measured it, feared it, and tried to outrun it. But the invention that could bend time offers a radical new possibility, to not just live in time, but to shape it. The question isn't just whether we can bend time, it's whether we are ready to. If this journey into the science of time blew your mind, hit like, subscribe, and join us for more explorations into the inventions that could change our reality.
Thank you for watching.